Hi, there's Mr. Rops,
And Mrs. Flynn.
and we are here to talk about area underneath the curve.
Okay, so if we
in
look at
calculus.
oh yeah,
Exactly. Go ahead. Yep.
If we look at the first example, it says find the area under the curve of f of x, x to the third minus x plus 1, and the x-axis. So it's asking us to find that from the x-axis over the interval of -1 to 2.
Right.
So we're looking at that right
all
there.
this area here. We're going to find how much that is. So you have to imagine putting an infinite amount of skinny rectangles and then adding up all those sums. Now that's hard for us to do by geometry, so we use calculus to our rescue.
Yay!
Yay! And so we're going to find the integral from -1 to 2. And this is of
X to the third minus x plus 1 dx with respect to x. Okay.
Right. So now we take our antiderivative, and I get power 4 divided by 4 minus a half x squared plus x. And we're going to take this from -1 to 2. And we're going to plug our values in. And we get 1/4 to the power 4 minus a half to the squared plus 2. Now, be careful with your minus signs.
Yeah.
They are everyone's nemesis.
Just make sure to put that, subtract the whole thing in parentheses too.
Right, and I usually try not to take off the parentheses too soon. I try and do lots of calculations, simplify inside. All right, so let's do this together. 2 to the power 4 is 16 divided by 4.
2, so 4.
4 minus 4 over 2 is 2 plus 2 minus, I'm going to keep it in parentheses for now, and this will be
It's even exponent, Nicholas. You know this one? It is.
1.
We were talking
Positive
about
1.
negative and odd exponents of negatives. Okay.
Minus a half, because this is 1 again, minus 1. Okay, and so now we keep on doing our computations. Well, I can see that those cancel away.
So we're left with just 4 minus, and now we have a fourth minus a quart or half.
All right, so let's say this is 2/4
And
minus
4/4.
4/4. So I get 4 minus, well, that's 6/4 negative, plus 1 is minus 5/4, which is going to be, changing this to fourths, I get, 16/4. Those two minuses become a plus, 5/4.
Lots of fraction practice here.
It is 21 over 4 is our area underneath here.
So we could say 5 1/4 if we wanted to, or we could leave it as 21 fourths, and that's the area under the curve.
Right. And so we could do that with our calculator. And if I come to my calculator here, you can see that I've already got the function here, and if I graph it, I'll find it. And if you want to follow my keystrokes, here's my keystrokes, and I'm going to clear it. If you want to see what my keystrokes are, I'm going to go second trace, which is my calculate menu, going down to number 7. And I'm going to take the integral. My lower limit is -1. Oh, too many negatives. -1. And my upper limit is going to be 2.
And then the calculator does all the work for you.
It does, and if you see from the picture, it's really nice. It even shows you what area it was you were trying to find. And
Ta-da!
Ta-da! 5.25, 5.25. Hooray! Okay, shall we do another one?
Sure.
All right, this one's almost exactly the same. We're asked for x cubed minus x minus 1. So let's take a look at, and I'm going to get rid of my history there.
We probably want to make sure that we look at the graph here before we do anything.
Right. Because we took you through the steps, but there's a little bit more thinking that really needs to be involved in doing these. And so if we graph here, I get this function here. And let's pull it over so we can talk about our graph. The question is asking us to find the area between the x-axis and that curve. So from -1 to 2. Now, if we just do pure integration, this area is considered a negative area. But if I'm asked to find the area underneath the curve between the x-axis and the curve, I want to make this a positive area. I want to know.
So then we get the total area and they don't subtract from each other.
Right, exactly. I want the total area of the two. And so one of the things I can do, which is actually quite clever, because I know I want to go minus 1 to 2, and my function is x cubed minus x minus 1 dx. That would say negative plus this area, and I'd probably end up with a negative area. I'm not looking for that. But if I would take this function here and do something so I would get that function, this area underneath here would be the same as this blue area. What will take all my negative values and force them to be positive? What will do that? It will be absolute value of that function. So if I take the absolute value of that function, then it will find me that red area plus this area, which I'm making red now as well. Now, I can only do this if I have my calculator, though.
Okay.
Happily, I have my calculator. So let's go over here and let's insert my absolute value. Number, absolute value. Oh.
Dang it.
Which is right. All right, so x to the power of 3 minus x minus 1. And I have to delete all of it.
Oh no.
Oh no. Let's go to the end. Delete, 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 delete.
It gives them time to do this on their own then.
Right, exactly. And then you'll know the pain I'm going through with this. And you can take the time to do it in your page. Why is it not getting rid of that exponent? There we go.
You gotta put your 1 in too, yeah.
Minus 1. Okay, let's graph it, see what we get. And so here is the graph we were looking for. And I'm looking for the area between the x-axis and the curve. So if I go second trace, number 7 is my integrate. I'm going to go from negative 1 to 2. And I can see that my area is 3.62. So this equals 3.62 to 3 significant figures.
So what if we didn't have a graphing calculator? Then what would we do?
Well, in this particular example, it would be quite hard. Because we would have to find this value here. And then let's talk about conceptually what we would have to do. So I would have to find that value there. Let's say it is a. I know I'm going from negative 1 to a and then a to 2. I would have to find the integral from negative 1 to a of my function x cubed minus x minus 1 dx. Recognize it was a negative area, so I would want to make it a negative to make it positive altogether. And then I would have to add the integral from a to 2 of the same function dx. And I would have to do these separately.
So there's 2 separate calculations of where it intersects the x-axis.
Right, because this is my negative area. That is the blue area up here. I would have to make it a positive.
All right.